Recently, Photonics Media visited Princeton University, where mid-infrared spectroscopy is a major focus of research. Environmental sensing is one application explored in Dr. Gerard Wysotsky's Pulse Lab, where we take you in this week's EDU Spotlight.
Hi, I'm Gerard Wysotsky, and my laboratory is focusing on research that is concerned with chemical sensing using optical methods, and we start with fundamental analysis of laser-matter interaction, then develop new systems that actually can measure chemical compounds in different media, in the gas phase, liquid phase, and we try to apply those techniques and build systems that are user-friendly and can be used to explore new applications. I'm not the chemist by training, however, we learn from chemists how they want to identify substances, how they want to perform analytical chemistry, and we try to apply our knowledge in signal recovery, modulation, demodulation techniques that are actually useful to enhance sensitivities of some of this new sensing, spectroscopic sensing technologies. And this interdisciplinary character of the work helps us actually attack new problems.
One device under development in the Pulse Lab puts a twist on light polarization to extract chemical data, as graduate student Eric Zhang explained.
And what this instrument is a Faraday rotation spectrometer. And so it detects the polarization change of light as it passes through some sample gas. In our case, this is nitric oxide, and so there's a polarization rotation that we can detect, and this is on the order of 10 to the minus 9 radians. So what's really new about this is actually the ability to perform optical subtraction. So we have 2 gas cells instead of 1, and so what we can actually do is we can detect some sample gas with direct respect to some reference gas that is really well known. And by doing this, we can actually perform a really precise isotopic ratio measurement that's currently under development. And so this is going to be specifically targeted geosciences applications, so environmental monitoring. And so, for example, one application is to look at isotopic studies of seawater. And so by looking at these very small changes of isotopic ratios in seawater, which we are capable of, we're going to be capable of detecting, we can actually determine, for example, the productivity of phytoplankton or productivity of vegetation and so on in terms of producing, in terms of fixing nitrogen in the atmosphere. And so this provides us insight into past climate changes.
Pulse Group members have developed another kind of spectroscopy based on phase changes, which graduate student Genevieve Plant recently tested in the field.
So this is an instrument to quantify methane, so specifically natural sources of methane, but it could also look at things like fracking or leak detection along pipelines and things like that. So this technique, the system utilizes chirped laser dispersion spectroscopy. So this is a technique developed here in the Pulse laboratory. And it's different from standard absorption-based techniques because it probes the optical dispersion. So instead of looking at how much light is attenuated by the presence of your target molecule, you look at how it changes the phase or the frequency of the light. So this was taken to a site in New Hampshire to look at emissions from fens or wetlands. So trying to quantify how much methane is released from these sources, so from these wetlands, and released into the atmosphere and how they're mixed and things like that. If we understand the natural emissions and where they're generated and also where they're captured, so sources and sinks, then we can better understand how anthropogenic sources from the various man-made sources play into the greater scheme.
While we were at Princeton, we also visited with researchers exploring mid-infrared biosensing and other applications for quantum cascade lasers. We'll have more on their work next week on Light Matters.
Until then, you can get in touch with us at lightmatters@photonics.com. You can also follow us on Facebook and Twitter for news updates every day.
Thanks for joining us. We'll see you next time.